To solve a log equation, we're going to go back to our definition of logarithm, which was the log base a of x is equal to k if and only if a to the k is equal to x. So we're going to start all of these problems by rewriting our log equation as an exponential equation, and then it should be easier to solve from there. So log base 81 of x is equal to 1/4. As an exponential equation, this would be the same as 81 to the 1/4 is equal to x. And remember, an exponent of 1/4 is the same as a 4th root, and the 4th root of 81 is 3. Log base 2 of 7x equals 5. As an exponential equation, this would look like 2 to the 5th is equal to 7x. And 2 to the 5th is 32. And then to get the x by itself, we just need to divide by 7. So x is equal to 32/7. Log base 9 of 2x minus 3 equals 2. As an exponential equation, that would look like 9 squared is equal to 2x minus 3. 9 squared is 81. And then to get the x by itself, we need to add 3 to both sides. So 84 is equal to 2x. And then divide both sides by 2 so that x is equal to 42. Natural log of 6x plus 9 equals 2. So remember, natural log is understood to be base e. So to rewrite this as an exponential equation, it would look like e squared is equal to 6x plus 9. And then to get the x by itself, we want to subtract 9 from both sides. So we have e squared minus 9 is equal to 6x. And then to get the x by itself, we need to divide both sides by 6. And now because this one has an e in it, we're going to end up with a decimal answer. So we're just going to plug all of this into our calculator. You'll probably need parentheses around the numerator. So parentheses e squared minus 9, close parentheses, and then divided by 6. And when you do that, you should get approximately negative 0.27. Log of 6x equals 3.7. No number there. This one's understood to be base 10. So as an exponential equation, this is going to be 10 to the 3.7 is equal to 6x. And then dividing both sides by 6, we get 10 to the 3.7 divided by 6. And again, this is one because we've got this decimal number as an exponent. We just want to plug into our calculator to get a decimal answer. So for this one, you should get approximately 835.31. Log of 10 to the x equals 2.3. This one is again understood to be base 10. So rewriting as an exponential, we have 10 to the 2.3 is equal to 10 to the x. And now since we have the same base, that means that our exponents are also the same. So x is equal to 2.3. Log base 3 of 9 to the 6x equals 4. So rewriting as an exponential, we'll have 3 to the 4th is equal to 9 to the 6x. And then remember, to solve an exponential equation, we want our bases to be the same. So we can turn a 9 into a 3 by squaring it. And then since we're raising an exponent to another exponent, we can multiply. 2 times 6x is 12x. And now that we have the common base of 3 on both sides, we can set the exponents equal to one another. So 4 is equal to 12x. And then dividing both sides by 12, we end up with x equals 4/12, or reduced 1/3. Here again we see an exponential equation, so we want to get the same base on both sides. 64 is the same as 8 squared. And now since both sides have an 8 as its base, we can set the two exponents equal to one another. Log base 4 of x is equal to 2. And now we're back to solving a log equation, which means we want to rewrite it in exponential form. So this one would look like 4 squared is equal to x, and then 4 squared is equal to 16.